Hi, everyone. Thank you for coming for presentation. I'm Jordi Vaquero, and I'm the lead of the software team in Semidynamics. I'm going to talk today about the Aliado software development kit, or the Aliado set that we like to call in Semidynamics. Aliado is the software stack that we are providing in Semidynamics for all our customers. It works seamlessly for every kind of hardware that Semidynamics provides. It can be the emulation of the QEMU that we are providing. It could be the FPGA emulation that we have for our solutions, or we can even the ASIC that we have for our chips. For that, we have a set of libraries as well that helps you to develop and to work with that hardware. That includes our kernel library, our toolkits for bare metal and Linux environments, as well as our compilers provided from Semidynamics, and as well for ADA and our AI frameworks. But let's gonna get a bit deeper on that. What is our software stack? Aliado software stack is two parts. It's the Aliado SDK itself and the Semidynamics ONNX runtime. The Aliado SDK, it's part of our Eclipse-based IDE that you can use to help during your development, that provides connection seamless with your GDB and our own compilers. For compilers, we have provided our own flavor of the GCC and the LLVM that are tailored for our applications, and as well includes our proprietary instructions. We have changed slightly the compiler just to make sure that all the scheduling the application and everything are working the best with our own hardware. We provide as well our own QEMU version for Semidynamics hardware. It's a functional emulation of the hardware itself. It works exactly as it will work in FPGAs or in the real ASIC. And everything goes together with the Aliado kernel library. That is the key part of everything together. Aliado kernel library is a highly optimized set of functions and operators to use in your AI inferencing as well in your applications. Everything supports total parallelism in our environments. For inferencing, is the second part of it's the second stack, right? So we are fully supported by ONNX as an open neural network exchange. Everyone probably works in AI, understands ONNX and knows what ONNX is, but basically it's based on two parts. It's based on an ONNX format that is a graph format that is becoming a standard ad hoc in the market. Everyone and all the frameworks understand or be able to translate to ONNX. But ONNX runtime itself is able to provide a set of tools to help you during that process. The ONNX optimizer provides and optimizes the graph, prune if it's necessary, for the supported operators that you have. The transformer optimizer optimizes specifically for LLMs or transformer-like models. And the ONNX quantizer provides as well a set of tools that help quantize your own models. All this is provided by ONNX as vanilla. We are not doing anything with that. It's just by the framework itself. So what Semidynamics does? Semidynamics created their execution provider inside ONNX for supporting different kinds of hardware. ONNX has what they call execution providers. It can be for NVIDIA hardware, for example, and we are adding our own Semidynamics execution provider that, connected to the already mentioned Aliado kernel library and our drivers and connection layers, will talk directly with the Semidynamics hardware. That hardware and that execution provider is able to work in different environments. As it can be in a self-hosted environment where Aliado works as a main CPU with AI capabilities, and it will run the ONNX runtime at the same time it runs as well the acceleration part of those models, or it can run in an accelerator mode. In the case of the accelerator mode, we can provide a different sets of connections connected to the host, if the PCI Express connection card, for example, or an AXI-bus connection that will be in a die-to-eye connection in the same chip. Aliado contains a Aliado communication layer that seamlessly connects the host with the accelerator card or the accelerator chip, and communicates asynchronously. So you're sure that you're not going to get any kind of delay or latency just because of the communication itself. Everything is taken care of for our communication layer. These are the key points of our SDK, right? But the main part of the Semidynamics likes to always comment is that, okay, is this easy? Are we future-proof as we like? If we analyze slightly what happens in the market of the models during the latest 10, 20 years, we can see that in the 2010s, everything was about convolutional neural networks. 1012, AlexNet appeared. Everyone liked to do object detection with images with convolutions. 2017, MobileNet created their efficient convolutions. Everyone wanted to do a convolution. Everyone wanted to really analyze what a convolution has, doing it faster. YOLO v3, that one marked a different step, appeared in 2018. But 1 year earlier, Attention is All You Need paper from Google appeared, and everyone was a big snowball coming out to, we don't care about convolutions anymore. We just care about models. 2020, ChatGPT-3 appeared. Everyone cared to do big matrix multiplications, but in generative models like LLMs, after the first prompt analysis, everything becomes a vector matrix multiplication, not a matrix multiplication anymore. But 2024, MatMul, free language models appears, claiming that last year, claiming that they can do the same kind of work with the same accuracy without MatMul based on 1-bit LLMs and 1-bit models. And the latest, in 2024, DeepSeek appears with the multi-head latent attention layer. 2025, DeepSeek Rational 1 appeared, and everyone was claiming that DeepSeek was doing what NVIDIA wasn't able to do with half or 1/10 of the price. So what this shows you is that the AI market is changing. It's continuously changing, and every solution you are doing fully tailored in hardware for it, when the moment it's taped out, is going to be already outdated. So let's going to make a quick example. Is Semidynamics future-proof? We think it is. So with Semidynamics is fully programmable, and with the highly optimized set of libraries and operators we have, we can reuse the hardware thanks to the vector instructions. And when the RISC-V spec doesn't arrive, we can have your own custom instructions to reach where it doesn't get. But at the same time, we have a strong RISC-V ecosystem that helps everyone that does a RISC-V core, doesn't need to do everything by itself. We ourselves help in the QEMU, in the work already done in the QEMU for RISC-V emulator to base on, in the GCC and the compilers work that was done before. And that's a strength, not a problem for us. So let's make a quick example. We talk about DeepSeek, right? DeepSeek R1 appeared in January 2025, a couple of months ago. And of course, most of the clients and the people we're talking about are starting discussing, can we run DeepSeek? Well, just quickly, you just go to Hugging Face, check the model. The model is 671 billion parameters. That's, for a floating point 16 model, that's a lot. That's more than a terabyte of memory. But really, DeepSeek is an MOE, is a master of experts. So really, the only activated version of it is only 37 billion parameters. That becomes 70 gigabytes of memory, something that is right now just for FPGA execution is not really usable. The same model of DeepSeek, in the same paper, they started talking about, okay, we did mini versions of it, distilled versions of the model. So let's gonna get what's the biggest one we can get. So we get one of the distilled versions. Can we run that? Sure. The DeepSeek model is in PyTorch. We are supporting ONNX. So what can we do? We just download the PyTorch model using PyTorch conversion of tools, PyTorch ONNX converter, just based on their own thing. We don't need to do anything. Converted the model easily to ONNX. The second step is, this is a specific model ONNX, but to get a real end-to-end user application for that. How you can do that? You just need to create your runner. Is your function, your main function that uses the ONNX application, creates a chat box if you want in this case, uses it, uses the ONNX runtime, configured for our execution provider. These are 2 lines of code, apart from the chat box itself, and run it in the ONNX execution provider. Can we run DeepSeek? Sure. Why not? All the whole process of downloading the DeepSeek distill, preparing the main, running it took like a week, less than a week. Most of the nowadays companies base their work for software in compilers to do all this kind of work. But this become a hassle. Yes, compilers is the easier way to get something up to running. But is this an end-to-end user application? No. We provide a whole set of framework to help the customers and the customers of our customers to create their own set of tools easily, simple, and quickly. How can you get the SDK as we have it right now? Just can go to our webpage, go to developer section, Aliado SDK, and request access to download it. As simple as that. You have access to our EQEMU to functionally analyze your code, checking that it works with everything, access to the binaries of our libraries, and if you want to try in a real FPGA cycle accuracy environment, you can request access to our evaluation platform and run it and get your own estimation of cycles in a real FPGA environment. It's using AI doesn't need to be complicated if you have the right tools. Thank you for hearing. And if someone wants to discuss this more or have any questions, I'm going to be available.